Okay, as it is 17:05, I suggest we start. First of all, hello everyone. Thank you for joining this workshop, for agreeing to give a talk or give feedback on our software projects. I guess you are all familiar with our schedule today, but just in case, I would like to remind you that we have first two talk sessions. The first one dedicated to the updates of the TVS software projects, and second one from our guests from other brokers. Then we'll have a short coffee break and a discussion and breakout session with an exact set of breakout rooms to be decided together after our talks. The recording is on, so if you don't feel like showing up on the recording, please don't turn on your camera. And there is a little detail about the organization of this workshop. The thing is that unfortunately, Federica and Rachel had conflicts with their schedule. So we are running on Federica's Zoom license, to which I don't have like a direct access. So we have one co-host of this meeting, which is Riley Clark, who kindly agreed to be the co-host. But just to be on the safe side, I would like to ask for a couple of people to also be co-host in case my connection breaks and we will need to re-enter the meeting. I was thinking about asking Angelka and Tomislav, as you are quite experienced, if you plan to stay throughout the meeting, may I ask your permission to make you co-hosts? Angelka, yes. Okay. And Tomislav as well. Thanks a lot. Okay. 1 second. Excellent. Thank you. Other than that, the last notice is that if you plan to discuss something important or send some materials, please don't use for this Zoom chat because it tends to be completely cleared out when we are entering breakout rooms and come back, and use Slack channel as well instead of this, the one created specifically for this workshop. That's it. Another last minute change. One of our short talks speakers, Alex Maltz, also has a conflict with his schedule for the first hour. So he asked to move his talk a little bit later. So probably we are going to have this talk after the broker sessions before coffee break. Other than that, I think that's all. As it was already several times mentioned, the purpose of this workshop is to inspire communication between software developers, potential users, developers of the other software that require some inputs from different teams. So the most important part of this workshop is going to be discussion. So please stick to it and be present. I think it is going to be very important and very live. And other than that, we are ready to start with our short updates on the TVS project, projects. Let me share the screen. And let us begin with our talks. Just a reminder, the algorithms is like this. First, we have a talk and then a short 2-minute time slot for questions. After we run through all the talks and after we have a broker sessions, we will have a discussion session, which is a place to have all the advanced tutorials, explanations, discussions, and so on. That's about it. And please tell me if you can see it and hear it properly.
Alex, we cannot hear if you have already started it.
Uh-huh.
I think you want to go to the top of your screen and view
Yes.
options. And there should be an option for sharing your computer sound. Actually,
Let me check it.
Riley knows better than me about this option.
Let me check.
Yeah, I think that when you share in Zoom, there is an option like a tick box to share the sound as well.
Yes, probably unshare and reshare, and it will ask you.
Okay.
At the bottom left of my share window, when I see which window I want to share,
Share
there is a
sound.
share sound option. Yes.
Share sound, exactly. Okay. Let's see if it works this time.
It is not working. Are you hearing the sound?
Yep, but it doesn't work for you, right?
I think it might be because you are the sound is going to your headphones. So that might overwrite the share sound. So you may want to go to your mute button and select a speaker your same as system. The mute button in the Zoom window on the bottom left.
Did it work now? I guess not.
No. Are you
Okay.
Are you no longer using headphones?
I used sharing the computer sound.
I think, yeah. But you're still
Anjoka, I apologize for using your records as a sort of guinea pig. We will figure it out so soon.
No, that is fine. And if you would like, I can help and just share the presentation and pass in 2 minutes through the presentation. That's it. If it is easy for you.
Well, there are some talks that are completely.
Well, somebody pointed out
in
that the YouTube volume is really low. So do you want to try it again?
Can you hear me now?
No, but it's not. We can still hear you.
I won't be hearing you.
It's not playing though yet, is it?
I don't think you hear anything, right?
No. When you have your window at the bottom left of your Zoom window where it says mute and you have your microphone.
Yes, same as system. Let me try like this.
Both for the microphone and the speaker?
Yes, currently, yes.
All right. And I had to go back to teaching, unfortunately, so I can't share it, but maybe somebody else can try and share. Everything is on YouTube, right?
Yes.
Riley, could you possibly try and share your audio on your screen? You had success with that earlier when we worked on sonification software.
Yes, I can try. Can you post a link in the chat, possibly?
Yes, 1 second.
We didn't think about rehearsing this.
Yes, unfortunately, our rehearsal session wasn't rehearsed enough. Riley, can you check the?
Yep, I've got it. Let me see if I can share my screen. And I will share computer sound. And please let me know if you can hear this.
Welcome. My name is
Yes, we can.
Kovacevic. I'm
Yes,
the
we
lead
can.
of CERSAG-1
Hallelujah.
interactable software team. On behalf of our team, together with our project manager Dragana Ilic, we report on key technical updates of work on time domain periodicity mining pipeline for AGN and stellar light curves, which can complement and help other LSST pipelines in frequency domain. The chart shows our in-kind speed through the milestone system over fiscal years from kickoff up almost today. We have received positive annual reviewer report from the IPC office. The most recent version of the modules are stored in separate GitHub repositories. The pipeline's 2D hybrid core, which calculates the correlation of wavelet matrices, has been modified to employ superlets for deep learning light curves, in addition to WZ method for non-homogeneous cadence light curves. At the center of slide, we see the portion of the beta catalog of calculated periodicities and their errors for 1,000 quasars from LSST AGN Data Challenge database. Beside this, we also simulated 1,000 light curves for selected obscene cadences and with injected periods. We see on the right the heat maps representing the relative errors of detected periods for various level of amplitude of signal and LSST cadences. The relative error is up to 1%. We are in early stages of testing, developing and prototype testing, which are performed only at developer machines. We will share the first example notebook for simulated LSST AGN red noise light curves with inserted periods for testing during the TVS software workshop break rooms in order to receive early input from the community. We hope you will test our notebook at TVS software workshop. Your feedback matters, and we look forward to meeting with you soon. Thank you so much for your time and attention.
Hello, my name is Kostya Malanchev. I'm postdoc at University of Illinois.
Riley,
Champaign.
please
And today I
pause
present to you light curve feature extractor.
the talk, since we plan to go one talk, one question session. If it is okay with everybody. Then please questions for Angelika and Dragana regarding their periodicity finding algorithm. I guess I will go with the first question. Angelika, am I correct that you are developing your algorithm primarily for AGN periodicity finding? Am I correct?
Yes, that is actually inspired and oriented to the AGN light curves, which are presumably red noise light curves, but also we intend to test it on some provided user cases of stellar as well light curves.
Mm-hmm.
So we provided, as you already seen, we provided initial test demo test notebook, which can be run on Google Colab, and it actually depicts generation on simulation, of the red noise AGN light curve, and then injecting the period, and then determination of the period, its errors through Schwarzenberg-Czerny method, and also we imply Michael Johnson et al. From 2018-19 paper significance detection. Everything is packed in the initial beta version of the testing version of our pipeline. We also have another version of this package, which is oriented to implementation on AGN data challenge database light curves. So that is in developing mode.
And another short question is regarding how fast is your algorithm? So for how many objects it is realistically applicable?
Okay, so in the case, it depends. If you try to run this Google Colab, and you can see that wavelet is slow for long light curve, as you can see in our example, on 10 years long observational base, and for example, having thousands of points, which is not a surprise, because wavelets are more demanding for calculation. We also try to implement some kind of speed up actually through the memory, in the sense that we can take some data and then convert them, but the loss in accuracy can be significant. So if we take, for example, from AGN database, all features related to the light curves, timestamps and magnitudes, and then try to little bit change the type of the data and to convert them from float for higher float level to lower float level, then we have speeding up, but also we have some less accuracy. So because of this, we need the GPUs, and also we need large IDUCs, as it is Bura, and we are grateful to CPG IDUC lead Tomislav Jurkic and Lovro Palavesra, who is the lead of CPG team, for opportunity to cooperate and to test our pipeline on more powerful system, which is faster, of course, and more powerful.
Okay, I see. Other questions? Okay, if not, Riley, may I ask you to be the queer today?
Sure. Should I go ahead and start the
Yep.
second video?
Please.
Hello, my name is Kostya Malanchev. I'm postdoc at University of Illinois, Urbana-Champaign, and today I present you Light Curve Feature Extractor, a Python package for very performant extraction of features from regular time series, which we astronomy usually call light curves. So the package is written mainly in Rust with a bit of Python, and very performant, from few times to 100 times more performant than Python implementation of the same features. It has very rich feature set and implements some quite simple features like magnitude statistics, mean, median, momentum-based statistics, amplitude, and so on. Shape-based features like stress and key, and some more sophisticated features like peak extraction from Lobs-Cargill periodograms and parametric feeds for linear function and for transient-like functions. We also implemented some new features like auto-split extractor, which is very useful to classify recurrent outbursts versus eclipsing binaries. The code is very well tested and already in use by at least 3 ZTF LSST alert brokers, including Ampel, Antares, and Fink. And it is pip installable. You don't need Rust, you just need Python and type pip install light curve to use it. Here I show you a very basic example where I set up virtual environment and install Lightcurve and IPython. IPython is not a dependency of the package, it's just a way to show you the performance of it. And here I compare NumPy mean function with Lightcurve package mean feature extractor. And even for this very simple and basic example, Lightcurve package is few times faster than naive Python implementation. Thank you.
Welcome, everybody.
Thank you. Questions for Konstantin? Yes, Yanis, please.
Yeah, I just wanted to ask, can you actually use multiple bands? If you have data in multiple bands, can you use them and still look for variability in them, or do you need to use a single band only in terms of data sets? And what kinds of variability is it actually pretty good at finding? Is it eclipsing variables, or Lyra, or what kind of variables?
Great questions, Yanis. Thank you. So it will be the next big feature, which is coming really soon, maybe in few months or so. I hope it will come at the worst case until summer to have multi-passband features, and we plan a lot of them, including variability indices, multi-passband periodogram, and parametric fits. This is about multicolor, so it is not yet there, but will be soon. The second one, it is completely up to you. So it is not classification package. Yes, so it is just very performant feature extraction, and you could build any classifier based on it. I built a classifier for Elastic Challenge, for example, recently, and more or less successfully classified different types of variability there.
Yes, Tomislav.
Yeah, I wanted to ask, can you comment a little bit more about the speed of the light curve? And yeah, that's more or less what I wanted to ask. And also,
yeah, so,
did you run any tests to see how successful it is in recognizing, I don't know, eclipsing binaries and this kind of stuff, which can be quite problematic?
Okay, I'll start with the second question because it's really close to what we discussed. So again, it's not about classification. Yes, so you could combine these features, they have parameters. Yes, you could adjust them for a problem. You could build different classifiers. And there are not much, sophisticated features which there is, for example, no possibility to fold with period your light curve and extract features. Yes, so it's not built in. You need to fold it yourself. For example, yes, so extract period first, then fold, then find features. We tried different variable stars types and classifiers, and it worked reasonably well. About speed, so all these cheap features which do not have parameters which change quality for performance, so all these shape features, variability indices, magnitude statistics, if you have a few hundred observations, feature extraction could take less than 1 millisecond for all of them. Yes, so usually much less for one CPU core. And it has built-in parallelization with multi-threading, so you don't need to have troubles with Python multiprocessing, which is slow for low amounts of data. So the short answer that it is well under 1 millisecond, around 100 microseconds for cheap features, and for more sophisticated like periodogram and parametric fit, it depends on your quality requirements. Yes, so from milliseconds to tens, hundreds milliseconds for a few hundred observations.
Thank you, Tomislav. Apologies, Kostya. So any other questions? If not, Riley, can you please launch the next video?
Welcome, everybody. I'm Tamás Klenár, and I would like to talk about the LSST Hungarian in-kind contribution. So we are working with machine learning-based algorithms to classify variable stars, for example, positive variables, or eclipsing binary stars. And our goal is to create high precision classification algorithms with high level of reliability and speed, so we can classify thousands of light curves in just a couple of seconds. Our current state of work, I would like to talk about real data and simulated data. So we are using real data from ZTF and OGLE, where further cross-matching is pretty much needed to be sure that everything is working fine. The simulated data is coming from Elastic, and I would like to show you the results from this one. The cross-matching issue is still an ongoing collaboration with Tom G. Wilson and Tim Naylor. The current state of our work is on this slide. So the results are very promising. We are using phase-folded light curves. So these are images, and we are using numerical parameters as well, for example, periods and color indexes. We are using a couple of tens of thousands stars from the Elastic dataset, and we can classify about 10,000 variable stars in 2 seconds with very reliable results. We have a couple of things to do. So we need some further testing with different, for example, with different observation times, include some other variable star types, and we are still working on the cross-matching issue, and hopefully we can test our results on real data as well. So thank you very much for your time, and see you soon. Bye-bye.
Thank you. I see right away Yanis has a question. Please.
Yeah, so that's pretty nice, and this is exactly the kind of tool that will help other kinds of surveys as well. So say if I have my own survey, right, and I have, I don't know, millions of light curves of many objects, and I want to classify them. You said you used ZTF and OGLE, but isn't you've trained, I guess, your data set with OGLE and ZTF data. How efficient would it be in extracting types of variability, similar types of variability in other data sets that have different noise properties and so on? Have you tried it with some other survey?
So yeah, thank you for your question. These results, what I showed on these slides, are from the simulated Elastic dataset. So this was a very good way to try out to use the 6 different type of filters which LSST will use during this observation time. We used ZTF data, but as I mentioned, we have some issues with the cross-matching with the OGLE dataset. I think the best answer to your question is the problem with the sampling time, so the cadence of the measurements and the filters. So the simulated Elastic dataset will produce much different light curves, phase for the light curves, for example, like the OGLE dataset. So we have some trained network for the OGLE dataset, but the LSST-like Elastic data is a whole other story. We had to train our network a bit further to be able to use other sky surveys as well.
Thank you. Michael, I see you have your hand up.
Yeah, so if I can understand, so there's a lot of teams out there who've built classifiers for ZTF and OGLE and so on data. So is the deliverable here like public software whereby others can insert their own catalogs and just try to trivialize the ability to build a network? Is it the network itself? What exactly is the delivering thing being delivered here?
So our main goal is to be able to classify pulsating variable stars. That is our main project now. So what we will deliver is a pre-trained neural network which can use not just light curve data, but numerical data as well. So we will deliver this pre-trained neural network and some code for it, just to be for everybody to be able to use it.
Okay, thank you. Any other questions? All right, then let's move on. Riley, please.
Hello everyone, my name is Alex Radim, and I'm going to give you an update on the TVS Dash data portal, which is part of the Rutger Bošković Institute in-kind contribution, Directive 1, and TVS endorsed software. LSST infrastructure is already huge, including RSP, other brokers, and so on. And it's going to be even larger once actual scientific data releases start to come, since majority of science groups and collaborations are going to develop their own data products with additional access points, etc. We see Dash as a potential gateway for this kind of new software that would be developed within TVS community. So the main purpose of Dash is to provide an easy-to-learn web-based tool for the preliminary analysis of variability data within LSST data releases, with selection tools, simple plotters, light curve explorers, and so on. When some new algorithms are being developed within TVS, we would like to be the access points to these algorithms and provide a convenient place where all this new functionality can be gathered in one place. Since the last time we gave an update around a year ago, we finished collected user case stories and developing software requirement document. Design specification document is work in progress, as well as RSP-based Jupyter tutorials that would give a taste of the core functionality of Dash. And we are assessing what is going to be the backend technology. Considering that our tool is envisioned to be useful for ordinary users and scientists who are doing data analysis, as well as for those who are developing more or less massive algorithms. We hope to hear about your ideas and your feedback. And if you want to collaborate or have questions, please feel free to chat with me during the discussion sessions. Thank you.
Thanks, Riley. Okay, Jeremy, you have a question?
Yeah, this looks really exciting. How are you thinking about doing the integration of new algorithms? Is this something that would be done by the Dash team to bring the new algorithms in, or will there be some form of an API to allow experimentation with new algorithms?
Okay, so best case for us, of course, there would be APIs provided by the algorithm developer side, and then we would use these APIs for integrating them into Dash. It is realistic considering that we are part of the TVS software team, and a lot of people who are going to develop new algorithms within TVS software team, we are in touch with them, so it is realistic. However, obviously, if there is going to be a case when someone develops cool algorithm but doesn't have it implemented, for example, on one of the IDACs, but would like to have it available through Dash, then it is more complicated and it's going to be decided on the case-per-case basis.
Thank you.
Any other questions? Yes, let's first Michael and then Angelka.
So could you say a little bit more about how you're going about some of this back-end, front-end assessment? Because obviously there's a lot of things that look like this in the community currently due to the existence of surveys, and therefore, stuff like this has to exist, right? And so how are you going about kind of that assessment? Are you mostly focused on kind of building your own stuff from the ground up? Are you planning on probably adopting someone else's technology and extending it? Where do you expect the team is headed?
That's a great question. So currently, the most likely solution is that for the front end and some simple backend navigation, we are going to have some separate server, either virtual or just one of our institution ones. And everything calculation heavy is going to be relying on some light IDAX or IDAX computing capabilities. Regarding the precise technology, so front end it's Python, probably Django, and backend Python with some additions. Well, it depends on the algorithms that are going to be available through the Dash. But it is still very, very preliminary. Let's say I have two lists for each of these lists. I'm looking at the options and there is no hard decision yet.
Okay, but you are, but just to say it, you are going your own way then, right? You're saying that you're going to build your own stuff, is what I'm hearing. Yeah.
I would be glad if there was already a solution that I could easily adapt. I would be very happy about that, but I'm not sure yet. I mean, I'm pretty new in precisely this kind of projects, and I'm afraid that my own lack of experience is shown here. I hope that most of it is going to be adapted from something that more or less already exists. Anjoka?
Alex, thank you so much for this nice talk and very important tool, for example, specifically for our in-kind, as we tried, for example, because we will provide the catalog with detected periodicities, errors, significance, and then flags about the candidates. Are there reliable, medium quality candidates of binarity or very low? And we tried, for example, data shader on AGN data challenge database detected periods with our pipeline. And it provided some flexibilities to zoom in, zoom out, certain portions of heat maps we produced. However, I would like to ask you, would it be possible that we communicate with you related, you know, to our needs for visually presenting such large tables?
Yes, it is exactly what I have in mind for this project, because although the baseline is like preliminary explanation and light curves, etc., but as Michael correctly noticed, there are plenty of resources for this kind of stuff. I think that the strongest possible application for Dash is if we are going to work with TVS teams such as yours and provide good and, you know, high quality and flexible interface for your kind of data science products, which are maybe not going to be this easily and conveniently available through some other resources. So yes, absolutely, we would be very excited to collaborate with you.
Thank you, Alex.
Okay, any other questions? No, then Riley, please. Next talk.
Hello. So we are the in-kind contribution group from Heidelberg, Marcus and Yanis, and we want to very quickly show you the two things that we've been working on. Okay, so the first project was a high priority project, and the goal was to develop a user database member system. It's specifically designed to help TVS co-chairs share information with members of TVS and to maintain an up-to-date catalog of members and their contact details. It's our first directable in-kind contribution by Heidelberg University, and we've developed the software in a Python Django framework, and please join us in the breakout room for a demo.
So the second project would be the Observing Program Management System. And in the recent year, we have actually interacted with the TVS subgroups and with potential users in order to prepare the documentation and do the requirement analysis. This is another package that should be deployed here on our cloud server and will be tested in the core, and we will run tests in the course of the year in order to see with selected subgroups to see how that works. And
okay, so on our list to do next is to deploy the user database, get feedback, including today on the alpha version, and then we want to deploy it and register the users. And the next part is to develop the 2 demo OPM systems based on existing TVS user cases. And we have made significant progress with the user database, but we still need to, once that is complete, we still need to work on the OPM system. Thank you very much.
Thank you so much for your attention.
Thank you. Questions for Yanis and Marcos? I will have 2 questions then. My first question is, perhaps I am mistaken, but I think that Tom Toolkit that has been featured as a linked TED Talk recently, I think it has pretty similar functionality as OPM. Am I correct that there is is there an overlap of functionality, or is it completely different tools that you are developing?
Okay, so that is a great question. Actually, there were 2 talks that were given on similar systems. One was the one that ZTF uses, and the other one was the one that LCO has developed, okay, the TOM system. Now, I also worked at LCO, so I was partly involved in the development of the very early version of this kind of target observation manager systems, from which the TOM system later kind of developed. But what I had developed originally was tailored to a particular project. TOM then became very general. So my view is we want to look at both of these systems, see which features they offer, and we don't want to reinvent the wheel. If they do serve certain purposes that the TVS wants, we want to integrate those, but we don't want to rely exclusively on very particular solutions. So if one of them does better than the others, we'll need to decide depending on the project that that we want to do. So I think this is important when we need the user cases. What does TVS want to see in that system? Okay, now I expect that the system we will develop, we'll do the demo cases the way we understand it. We'll do some demo cases, and then users can contact us and say, okay, so this looks interesting. We want to deploy it for our own project. How can we do that? Now, this is not going to be relevant, I assume, for all teams. I mean, ZTF already has a really, really advanced system, and LCO also has a very advanced system running their own TOMs. But I suspect for everybody else that is not very familiar with these systems, it might come, as very useful. So exactly where we're going to go with this has not been decided yet. But yeah, we do not want to reinvent the wheel. If we can reuse something, we will reuse something. I hope that answers your question.
Yes, definitely. Thank you. Costa, I see your hand is raised up.
Yeah, thank you. Thank you. That's very nice talk. It's not really a question. It's just maybe invitation for further discussion, because I know that in Desk they are building the thing which is called Desk Tom and Desk FastDB, which is really close to what you are talking about, and probably it would be at least interesting to discuss what is common and what is different, and how different collaborations could learn from each other for different types of this system. Robert Knopp is a contact person probably for this in Desk.
Yeah, we should probably touch base with them, and we don't want to replicate efforts if possible. And the faster we get to a workable system, the better for all collaborations, I think. So yeah, I think we should definitely arrange some kind of discussion and see where they're going with it, and see whether it satisfies our needs as well.
Okay, thank you. I will leave my second question for discussion session. So then Riley, please, next video.
I don't think we need the next slide.
Hello, my name is Eric Fagelson. I'm an astronomer at Penn State, and I've been talking to statisticians for 40 years. I'm particularly interested in time series analysis, and of course, very interested in LSST. So I'm a member of TVS as well as the statistics collaboration. What I want to say in just 2 minutes is that it's really important that if you're spending time to develop a software package or capabilities for LSST involving variable objects, that you have to think about the methodology that you're going to be using. And it's not always obvious. The methodology available in time series is, I don't know, vast. It's unbelievably larger than the methodology used by astronomers. It's mostly in econometrics or in engineering time series signal processing. And the code is incredible amount of code. It's mostly in R or in MATLAB in the econometrics and signal processing toolboxes. So it's not in Python. Now R, anything in R can be wrapped into Python very easily. MATLAB is proprietary. So what I suggest is that if you're doing something that's sort of a little challenging, that you chat with a statistician. And I volunteer myself to be a consultant to you, just informally, to see whether I can help in any way with your problem before you write. I'm not going to help with your coding. It's the methodology that interests me. So feel free to contact me if you think I can be useful to you in any way. Thanks very much.
Okay, so I don't suppose that Eric is actually present here. I think he mentioned that he will have some clash with his schedule. But although it is obviously not an update on any project, I have to say that I constantly hear from some of my collaborators mentionings about some cool algorithms that exist in fintech, in weather analysis, something like that, and no one ever has time to actually look into these algorithms. So I believe it would be very interesting if someone experienced in this field gave a longer talk, maybe in one of our weekly software sessions, and discussed with us what are those algorithms and whether they are indeed somehow useful to us. Considering that Eric is not present, no questions for him, unfortunately. So probably Riley, next video, please.
Hello, everyone. I'm Drew Oldag, a software engineer on the Link Frameworks team. I'd like to briefly introduce a new template tool that we've been actively developing to help new Python projects get off the ground quickly. It's based on a technology called Copier. That's an open source tool that allows us to define template files that can be hydrated into software using responses to questions on the command line. The images you see here show a user responding to the template questions and the results displayed in a GitHub repository. Now, if that was the sum total of what the template was capable of, it probably wouldn't justify a presentation. But all of this is available from the very first commit, so batteries are included here. You get pre-commit hooks to verify your code quality prior to pushing to a remote repository, continuous integration to ensure that your code builds and passes tests with every PR, integration with code coverage to report changes and unit test coverage for every PR, automatic API documentation with Sphinx and read the docs, automatic publishing to PyPy when new releases are created, automatic periodic smoke testing for dormant projects to keep the lights on, and more coming soon. And many of you are probably familiar with Cookie Cutter and may ask why we didn't just use that, since it's been vetted in the field for a while. Well, the tool isn't actively maintained anymore, and one of the biggest flaws is fixed by Copier. The project hydrated from a Copier template can be updated as the template evolves. That means if you create a new project with the Link Frameworks Python project template today, and new features are added to the template next week, you can run a single command to pull those new features into your project. In fact, to make it even easier, we're working on a way to have project owners automatically notified when there are updates to the template. Oh, an additional note, you can also apply this template to an existing project. It's a little more work, but it's possible, and we've demonstrated it multiple times on projects that we own. So if you'd like to know a little bit more, please join us at the next Link Frameworks Tech Talk in April. I'll be presenting the template in much more detail, or take a look at the GitHub repository. And don't forget to add a star so you can easily find it again, or read through the documentation to get a better sense of how easy it can be to get a project started with the Link Frameworks Python project template. Thank you so much for your time.
Thank you. Questions for Drew? I guess I will go with the question. So the question is the following. I try to follow best practices and so on, and at least be familiar with the stuff. But frankly, like half of the technologies you mentioned, I am not familiar with them. So how do you think, how easy it's going to be for someone who is relatively new to proper software development practices and big scale software projects? How easy it is going to be for them to adapt your new template? Is it a matter of days? Is it a matter of weeks of reading?
Yeah, that's a great question. Part of the reason that we developed this template is because even for hardcore software engineers, adding all of these bells and whistles onto a project usually is something that takes on the order of weeks to incorporate. When you include all of this from the get-go, it just consolidates all of that time. It makes it much more tractable to get a project started. But more important than that, it makes it more maintainable in the long run. But to address your question specifically, just to understand all the various bits and pieces of technology that are bolted on the sides. Yeah, it takes a little bit of time and reading, but we are trying very hard to put together thorough documentation. And we're also trying to develop this template in such a way that if something doesn't seem like a piece of technology that you need right off the bat, you can exclude it when you create a new project. And then later on, if you decide that actually you want it, you can add it in later. That way, if it just seems too intimidating right off the bat, you can start small and build on gradually as you go.
Okay, thank you. Kostya, please.
Yeah, thank you, Drew. It was very nice talk and great project, of course. Is it compatible with LSS templates, and does it have in mind that there's already existing thing which a part of collaboration using for templates, of course, which doesn't cover probably pre-commit hooks and other cool stuff you mentioned? Thank you.
Yeah, great question. We are very well aware of the fact that there are many pre-existing templates, and the goal here is not to make one template that rules them all. That's not the mission at all. And in fact, the goal here is more to live either alongside it, or I would argue create a more basic template that includes all of these nice add-on features, and then let other science collaborations or other users fine-tune the template to their particular use case. So for instance, if you've got some boilerplate disclaimer that has to go at the top of every single one of your Python files, you can fork this template and add that for yourself. Another nice feature of Copier is it allows template composition. So you can use this as a base template and then create your own template to live alongside of it, so that you can, when you create a new project, pull in the base template and pull in your custom template as well. So yeah, long answer to your short question. We know there are lots of other templates. We're doing our best to get a good survey of the landscape here to understand what those all are, incorporate the best pieces of each one, but also build in such a way that it's extensible and other people can customize it as necessary.
Thank you. Okay, as there are no more questions, I believe, and I believe that this ends. This is the end of our list of updates playlist. Riley, may I ask you to switch to the broker alerts, alert brokers playlist that I just posted in the chat?
Sure. Should I go ahead and play the video?
Yes, I think we should go.
Okay.
Hi, I'm Tom Matheson, and I'm an astronomer at the NSF's National Optical Infrared Astronomy Research Laboratory, the NOIR Lab. I'd like to talk to you today about Antares, a fully functional time domain event broker built with a lot of hard work by the people listed here. Before I get into the details of Antares, I'd just like to take a minute to give a brief overview of all the work that NOIR Lab is doing to make a comprehensive time domain ecosystem that flows from time allocation to data reduction, so that you, the user, can focus on the science and not the process of doing time domain astronomy. First, We're adapting the time allocation process to be more responsive to the specific needs of time domain astronomy. We will also operate the Rubin Observatory, which will be the greatest astronomical time discovery engine ever built, with 10 million alerts every night. Those alerts will feed into the Antares broker that I'll describe in detail in a minute. We're also adding functionality to the Target and Observation Manager toolkit developed by Las Cumbres. We've added capabilities to interface with Noir Lab facilities and Antares. Again with Las Cumbres, we are developing the Astronomical Event Observation Network, a consortium of telescopes with common interfaces to enable coordinated observing. TOMs can directly interact with EON, even generating an entire Gemini observation within the Gemini Phase 2 tool automatically. Gemini is building a new, even more flexible scheduling system to accommodate time domain, and they are building a suite of data reduction tools, Dragons, for the Gemini instruments. But I'm here to talk about Antares. Antares was created to provide public access to Rubin alerts, so that every astronomer, regardless of the resources they have access to, can participate in the discovery space that the Legacy Survey of Space and Time will open. But it is also designed to operate at the rate and volume of the alerts that LSST will produce. It was built with modern technologies and is deployed right now on the Google Cloud platform. The flexibility of cloud operations has allowed us to test at scale to ensure performance at the LSST rate. Antares is one of the Rubin selected brokers that will receive the full stream, and we are working with them to provide their internal alert filtering service. Antares works by adding contextual value to alerts from extant multi-wavelength catalogs, and this runs the range of all the catalogs you might expect: Sloan, Gaia, Chandra, WISE. Virtually any major catalog you can think of, we incorporate. It also includes the past history of the object. If you have favorite sources, you can upload a watch list for direct notification via Slack if something alerts. You can have Slack make this notification as intrusive as you want if it's something that requires rapid response. We're actively processing the Zwicky Transient Facility public alert stream, although the weather in California has made that a lot less active recently. The technical details are available in the Matheson et al. Paper that I show here, that we published a couple of years ago. For those interested in the technology we use, we have Kubernetes for a containerized deployment so that we can stand instances up in a wide variety of environments. We use Kafka streaming technology to receive alerts and to transmit out filtered alerts. The database technologies are Cassandra and Elasticsearch, but we are moving from Cassandra to Bigtable in GCP as it will serve our needs better. We track the state of the system for provenance, and the software is all open source. We can easily integrate with the TOM as the Antares plugin is available for the Las Cumbres toolkit. This includes using the EON network directly, and from within the TOM you can access the alert database of Antares, and it is completely searchable from within the TOM. We've been collaborating with several other groups, including the Computer Science Department at the University of Arizona, Space Telescope Science Institute for integration with their archives. In addition, we have several downstream projects, including the SNAPS Solar System Broker, and they will receive the LSST moving object stream via Antares, just as they currently do from ZTF. The REFIT project at Purdue is using a substream from Antares to provide prioritization for follow-up of objects. And we've recently engaged with the Argus project to handle alerts. For Antares itself, the first thing you may see is our web portal. There you can see which filters are in operation, you can learn how to use the system, or you can explore the database of alerts. For each object, you can look at individual alert packets, and you can also see which catalogs are matched by that particular object. The key science capability of Antares, though, is that it can filter the alerts. In our case, filters are Python code that can use any of the features in the alert, including contextual information. It can also use information from the history of the object, or it can use information directly from the survey that produces the alert. Anyone can contribute a filter and have those matched alerts sent directly to them via a Kafka stream. And we have a Python kit, development kit that would allow you to set up this Kafka streaming service to your own machine easily. We will automatically associate alerts with multi-messenger events. When an MMA alert comes out, any subsequent event in the footprint will be tagged. Essentially, our system is built so that if you have an algorithm to find what you want that you can turn into a Python code, we can implement it right now. There's a filter development kit on the Noir Labs Astro Data Lab where you can use a Jupyter environment to see how to write a filter, develop your filter, and test it on real data. Here are some examples of filters that we're running right now. They can be simple, like, am I near a known extragalactic object? Or a brightness cut, or am I in Andromeda? But it could also be something complex, like a machine learning light curve classifier. We ran several machine learning classifiers recently for the Elasticsearch by standing up a separate instance of Antares within the Google Cloud Platform. We can also accommodate user-contributed catalogs, like the one listed here about likely hosts of tidal disruption events. Just to show you some examples, we ourselves are using Antares to do science. Mainly here, examples of finding unusual things in the ZTF stream. The anomaly filters that Monica Saraisam has developed for Antares have been very effective at finding weird things. Here's another example from a Jupyter notebook developed by Ryan Lau at Noir Lab, showing how you can use Antares and the Noir Labs Data Lab to combine data sets across wavelengths, but also across time with access to the time history of objects in these external catalogs. Having the data co-located with common interfaces makes this kind of exploration really straightforward. So Antares has many capabilities, and I don't really have time to describe all of the things it can do. The best way you can see how it works is to go to the website and see for yourself. Let us know play around with the system, see how it works, let us know what you want to do, and we'll see if we can help make that happen. Thanks for listening, and I'll be available in the Q&A session.
Thank you for this very interesting talk. Questions? All right, so probably the first question is going to be mine. Am I correct that you have an API that allows to have access to the majority or all of the Antares functionality? Am I correct?
Yeah, that's correct. We have programmatic access to all the features that I explained here that are available on the portal. So searching and other things. So yeah.
And if, for example, I want to do some massive data analysis and, well, obviously I can try running, if I understand correctly, I can try running my algorithms in your Jupyter environment, but I believe there is some limit in terms of CPU and memory or something like that. But can I, for example, using your API, download, I don't know, hundreds of thousands of objects of data of hundreds of thousands of objects? What are the limits essentially of API usage?
Yeah, right now for downloading that many, I think you'd want to talk to us and then we could arrange that for you. There's no open API that would allow you to do something on a large scale right now. But that is one of the projects that we're working on, we're developing right now in Google Cloud Platform, is to provide a sort of a system that stands next to the database that would allow you to operate over the entire thing. We don't have that in place just yet, but we do have an internal process that allows for a massive number of downloads. But you'd need to talk to us so we could arrange to do that for you.
Okay, thank you. Any other questions? All right, Riley, then please, next video.
Hello, my name is Francisco Forster, and I'm talking on behalf of the Alerce Broker. The Alerce Broker is one of the 7 community brokers of the Vera Rubin, and as you may have heard, it's an interdisciplinary collaboration that involves several institutions in Chile and also some in the US. We have a very interdisciplinary team that is composed of astronomers, computer scientists, electrical engineers, mathematicians. As you know, the future time domain ecosystem is going to be composed of several layers. So first, the survey telescopes, among them the Rubin Observatory, and that basically are going to be surveying the sky and detecting things that change in the sky. Those things that are more interesting will be followed up by follow-up telescopes, but in order for them to identify the most interesting objects, community brokers are going to become intermediaries between the survey and the follow-up telescopes. Community brokers will also connect the survey telescopes with the downstream brokers and TOMs, as well as the general user community. The products and services offered by brokers are many. Here I compile a list of what we have seen that is evolving with time. So initially brokers were just supposed to receive an input stream and output an output stream in Kafka, with adding certain information or filtering or classifying. And as time has passed, brokers are including many more services. For example, cross matches, watch list, detection of outliers, etc. The scientific questions that define ALERCE are basically four, and are in these four main lines. Questions about transients, variable stars, active galactic nuclei, and solar system objects. We have a special focus on the first three in this list: transients, variable stars, and active galactic nuclei. The ALERCE user community has grown significantly and now includes researchers or general public from 129 countries. So these are the countries where there has been at least one user accessing the ALERCE services. Because we are submitting the best supernova candidates every day from CDF, we have become the second group to have submitted more transients to the transient name server. And of the classified, spectroscopically classified transients, we are the third group that has reported the original candidate first. ALERCE is currently processing data from the Zwicky Transient Facility and Atlas telescopes. So in the public website of ALERCE, you will only see the CDF alerts and processing. But we have a version of ALERCE in staging that is also processing Atlas. What we do to process these two streams is to have a pipeline that's composed of several steps. Among them is a sorting hat step that combines and cross-match in real time the two streams. Then alerts undergo different treatments. So in one branch, we build light curves and we classify them. And in parallel, we do also the classification of the image stamps. This is for fast classification. So we have two main classifiers: the stamp-based classifier that provides, with a simple taxonomy of 5 classes, a very fast classification of objects with just one detection. And this has allowed us to submit very good candidates to the transient name server very rapidly. And a more refined taxonomy and classifier that is based on the light curve that includes 15 classes and can be used for more post-processing and analysis of the whole population of events. Both are available in our web interfaces. So the main web interface is the ALERCE Explorer, and here you can quickly query, for example, using the light curve classifier, all type 2 supernova, and see all the metadata, the light curve, machine learning classification probabilities, image stamps, contextual information from Aladdin, and cross-match information. For example, in this case, you can get the redshift of the galaxy. You can very quickly move between candidates using just the keyboard. So this has been designed to be very easy to use, very intuitive. And I would say it's becoming kind of a standard of how you can present these candidates. The other tool that ALERCE has provided is the Supernova Hunter. In the Supernova Hunter, you can quickly search for the best supernova candidates from the last 48 hours you decide, to quickly inspect these image stamps and basically be able to determine whether something is a likely supernova or not, or transient, extragalactic transient. We have other services. So we have an API that is open. You can access, basically do queries to the database through the API and do, for example, getting the probabilities, machine learning probabilities, classification, features. And we also have an API to access the CTF data release information associated to a given part of the sky. And all of this is also included in a Python client that is built to make the API queries easier. We can also, with the client, you can do complex queries, for example, defining the classifier, the probabilities, the number of detection, etc. And for more complicated, sophisticated queries, we can also provide direct access to the database, which is in PostgreSQL. Currently, this has a limit of 2 minutes per query. But if you want to do more complex queries, you can ask for access as well. We have many other services that I'll just highlight here. So the watchlist service, where you can submit a list of coordinates in the sky and get notified every time there is a change in these coordinates. You can access all the features that we have built, and here's the detail of what they are. We have integrated data release information into the Explorer, so you can see one example in this object. We have provided many use case notebooks built around different science cases with astronomers. We have we can provide a tool to automatically identify host galaxies. This will be soon integrated into the Explorer, but this you can pip install with the Astro Delight. That's the name. You can also, we are also reporting candidates to TNS, including host galaxy information and the redshift when available. You can here see some statistics. And we are participating in the Elastic Challenge. And so far, according to the information that is provided, we have the best accuracy, F1 score, recall precision, and overall completeness. So because of Elastic, we developed a new family of models using a different architecture of transformers, which we have submitted for publication. And here you can see the confusion matrix that we achieved with the training set provided by the Elastic collaboration. So Alerce is evolving all the time. We're now transitioning from CTF only with PostgreSQL to CTF and Atlas, which is in staging now using MongoDB, which is a non-relational database, and then to Rubin, continuing with MongoDB, most likely, and scaling to larger servers. Under development, there are many things happening that you don't see. Some are shown here. We are working on load balancing to make sure that all the services are scaled up in infrastructure as when they are required. We are changing the way we interact with the database to make updates to the database faster. So with asynchronous updates in batches. And we are working on new models that do multi-stream classification, not just with CTF, but CTF and Atlas. And here you can see a list of publications and different links for you to test and Alerce and learn about what we can offer. And finally, I would like to make an announcement. We are organizing a conference which will happen in December of this year, most likely the second week of December, which is going to be called Unveiling the Dynamic Universe, Cosmic Streams in the Era of Rubin. The idea here is to bring together all the broker community, in terms of users, but also builders. And it will be held in Puerto Varas in the Lake District in Chile, a very nice area of Chile. And we plan to visit some hot springs, as well as having very interesting scientific discussion. So I really hope to see you there. After the pandemic, we really need to start meeting in person again. So thank you very much.
Thank you. So questions. Okay, I have one question. So about the refined taxonomy of the light curves during the classification, what are so there are obviously some different quality of the classifications of different classes of objects. Are the worst cases caused by imbalance of the dataset and lack of the training samples for a particular class, or is it object properties and light curves are just too similar to the light curves of other types of the objects?
So I didn't hear you very well, but you ask why don't we have a larger taxonomy? Is it because of
No,
the
no,
unbalance?
no, I'm sorry. Can you hear me now?
Yes.
Okay, so the question was regarding your refined taxonomy of objects. Is the performance, the worst performance for some classes, is it caused by the imbalance of your training data set and lack of the training objects of certain classes, or it is just the properties of these objects, and for example, light curves are too similar to the light curves of other types of objects?
Yeah, I think it's both. There are some classes that you don't have many examples. So you even if we use this hierarchical balance random forest, you still have difficulties classifying. But I would say in the transients, they are intrinsically more difficult to classify because they are very similar among some classes. For example, type 1A and type 1C, they look similar. So I think it's both. And we see the same thing in Elastic.
But would it be possible to incorporate some additional data from, I don't know, maybe other surveys that are working in other wavelengths to improve the classification?
Yes, but in that case, you will have to develop a different type of classification model, because what we do, we train with CDF data to classify. So first we do cross-match against all the, to cover all the transits, for example, that are known in CDF, and we use this data to train. So for what you say, and I think that's something we all want to do, is to train with some other data and do domain adaptation or transfer.
Okay.
Yeah.
Okay, thank you.
I think we're moving in that direction. We will all move in that direction, I think, eventually, especially in the first year of LSST.
Thank you. I see Michael has a question.
Hi, really nice talk. Can you say a little bit more about what you're doing with Mongo and Postgres, like which part of the workflows you're using for both, and why? I guess Mongo for its sharding ability and that kind of thing, but just sort of the ethos behind those choices.
Yeah, it's basically, we believe that Postgres has some limit on how much you can scale it. And we also find that, we have changed the schema of the database many times since we started the project, and so that every time you change the schema, you have to populate everything again. So I think Mongo, apart from being, non-relational, it's more flexible to grow if you keep track, of course, of the different versions, scales horizontally. So I think these are the two main reasons. And listen to the experts. I'm an astronomer, and all the computer scientists tell us should move to non-relational. But yeah, I wish we could keep Postgres, to be honest. Yeah.
Okay, thank you.
I don't know if you have some views on this.
Okay, Julian. I see, Julian, your head is up, but we cannot hear you.
Is it better now?
Yes, now we can hear you.
Thank you. Thanks, Francisco, for the talk. So you have listed a number of services from LRC. My question is simple. Which kind of services is the most used by the users? And for the other one, what's the reason? Do you plan to decommission some services for LSST? What's your feedback after 3 years of ZTF?
It's a good question. My impression, I don't have the latest statistics. My impression is that the Alerts Explorer, just the web interface to look at the candidates, is one of the most used services. Even people that perhaps don't care about alerts, but I've seen people sharing the link to see the subject from the alerts interface. So I'm not sure how much the classifications are being used, for example, but I think, yeah, maybe it's because this is all too new and the community is getting used to working with these machine learning probabilities. We are also getting used to it. And I would say also the API to just query basic information. So the API has been very important, I think, to incorporate into, and the client to incorporate in the Jupyter Notebook, for example, to do some quick tests.
Thanks.
Yeah, but I will also be curious to know about your case. So we wait for your talk.
Yeah, you have a question. I would have a second question, if I may.
Yes, please.
Yeah, so concerning this conference, I'm super happy, and in Chile, moreover. Do you envisage like a conference with talks or a hybrid with hands-on session as well?
Yeah, I would like a hybrid thing. We can work together to define what exactly we want for this conference. So I was talking the other day to Emily, for example. We should get together and design this conference together. It's all open now. So we just are trying to secure the hotel to define the exact dates. That's the first thing.
Excellent. Thanks, Francisco.
Thank you.
Okay, thank you. And we are moving to the last talk in this session. Riley, can you please launch the
We need
video?
to start meeting in person again. So thank you very much.
Hi, I'm Julien, a research engineer in France and co-PI of Think. So in Think, we receive alerts from different survey streams. The problem is alert contains basic information, factual information. And if you want to do science, that's not enough. We need experts to extract the science. So in Think, we build the collaboration around the community of users. They provide science expertise to exploit the stream. We have more than 30 scientists worldwide that contribute to the project nowadays. And our ambition is not to restrict ourselves to a particular topic in the transient sky, transient and variable sky, but our ambition is to study the transient sky as a whole, so from solar system object to galactic and extragalactic science. So here is a non-exhaustive list of ongoing science projects. I won't go into the details of those, but you have links to submit your published papers already, small description on their focus. But you can see it's quite broad in Think, but it's not the work of a single person. Each project is a science project team with one or several people inside. So how Think works under the hood. So the stream, and even for the Zwicky Transient facility, is quite big, and it will be even bigger for LSST. So if you want to keep doing science as usual, we need to develop tools and infrastructure to enable this science. So in Think, we have expertise to operate in real time on very large cloud computing infrastructures. Currently, we are deployed at the Virtual Data Cloud here in France since 2019, and we are now migrating at the computing center of IN2P3, which is the center that will also process 50% of the LSST nightly images. So roughly speaking, what's happening? On the left here, you have the main streams that are entering Think. So currently we are working on ZTF, but soon there will be Robin. So the alerts are entering this box. This box is a cluster of machines that will collect the alerts and extract the science based on the science modules that I will describe later. And for doing that, we are using the Apache Spark framework, which is a framework for doing distributed computation. As soon as the data is processed, it is sent via Kafka stream into the users for eventually follow-up, for example. At the end of the night, all the data that's been collected and processed is pushed into our database. And for that, we are using Apache HBase, which is a NoSQL type of database. Quite nice to handle the large volume of data that we have. So this data is put into database, and you can access it later on for further analysis or visual inspection directly here. So that's the idea behind Think. So in practice, as a user, how would you interact with Think? One core element in Think is the science module. So as a user, you can see Think as a platform for doing transient and variable science, in the sense that we provide tools and expertise for the big data side. So you don't have to worry about that. And you only deal with the science, as usual. And here I quote basically the description between Think, the Think team, it's a core team, and the community of users. And we are pretty clear that each community project team is completely self-governed. So groups are free to decide on how they should organize management, work meetings, and how they choose team members. And the Think project are responsible for their work and get full credit for their results. So you do science. You do the science as usual. So in practice, how it works, you have an idea and you contact us. So we brainstorm, and once we are happy with the roadmap, we design the module together. And we deploy the module into Think. And so, for example, here is the current list of modules that are deployed and producing added values. So we have module focusing on cross-match. So it will cross-match any incoming alert with external catalogs. And we have cross-match with the CDS database, with GCVS and VSX catalogs for variable stars, with Gaia, DR3 release, with 4LAC and 3HSP, which are mainly for AGN and Blazor, and the Mangrove catalog, which is a catalog of Galaxy, mainly used for gravitational wave follow-up. We have also modules that are focusing on machine learning and deep learning techniques. They are applied currently on supernova type 1a, but also broad supernova and core collapse objects. Module focusing on microlensing using LIA. Module focusing on kilonova. We have also broad modules. So instead of focusing on a particular type of class, they would provide a vector of probabilities for many classes. And this one is using transformers technique. And we have also a module focusing on detecting anomalies in the stream. And for that, it uses a lot of light curve features described in that paper, that link. We have also more standard modules, not as clever as machine learning and deep learning, but nevertheless important, especially for solar system object linking, for example. So going back here, oops. And once your module is deployed, it will provide added value in the stream, and this added value is accessible from all Think services that will be described very soon. So since 2019, we are operating on the ZTF alert stream. We received more than 170 million alerts and processed 140 million. The difference between the two is due to the quality cuts that we apply to the stream to keep only alerts with the best quality. If you take like a typical nightly rates of 200,000 alerts and you break it down into Think classification, you can see that there are, well, a lot of them are known variable stars. A lot of them are also known solar system objects, but you have also new objects like new solar system objects, new supernova and core collapse candidates, AGN, satellite glints, 1A candidates. One per night can be considered as a fast transient candidate, so that includes kilonova candidates, gamma ray burst, cataclysmic variable, a lot of stuff that basically rise or decline very fast. Typically, we have one new microlensing candidate per night. Well, false positive rate is quite big, and one anomaly also per night that we should pay attention. This is basically a projection of all the alerts taken between 2019 and 2021 on the sky. You can see clearly the galaxy here, the galactic plane. You can, well, guess probably like the ecliptic plane with the solar system object, and the rest are extragalactic objects mostly. You can flash those QR codes, they will bring you directly to the science portal of this object. And if you zoom in the galaxy, you can even see its structure through the distribution of alerts, which is quite nice. So how do you access data in Think? We have mainly four services. The first one is called the live stream. It's used for live inspection and follow-up. You can design filters to decide which data you want to access in Think based on the classification and added value that we provide, but also all the initial data from the alerts. Second service is called the Science Portal, which is a web application based on Dash. I know you're using Dash for your dashboard. And there is a corresponding REST API to access the data programmatically. It's used for visual inspection, small volume queries, and daily monitoring. So if you click on that one, up, you will enter here. You have a search bar. You can perform search by object ID if you know it, cone search, date search, class search. So if you click on class search, up, you can search by a given class, and we have more than 100 different classes that you can select. So if I zoom in, for example, if I click on AGN, I take the last one up, it will open its corresponding page for this object. It takes a bit of time, a lot of data. And here it is. So you have the light curve in the middle here. Zoom. The light curve here. You have the evolution of the classification. This one doesn't evolve much. It's an AGN. Here you have Simba applet that give you view of the image, and here you have the cutouts, so the small images contained in the alert. And if you click on that, first you see better, but you can also choose the given date if you want to change and see the evolution of the images over time. Bring back to here. We have also a service for data transfer. It allows you to do bulk download, complex queries. It's heavily used in Think for machine learning and deep learning training. And you can also run exotic analysis there. And obviously we have a TOM module, so an extension in TOM for Think. We are preparing ourselves for Robin through the Elasticity Desk Elastic Challenge mentioned by Francisco. We are building partnership also with many different experiments, and we are often collaborating with other brokers, which I think is very important given all the difficulties that we'll have analyzing the Robin data. We are running typically 1 to 2 events per year, in-person events. Last year we had the Think collaboration meeting and hackathon, focusing on several hot topics for Robin. And this year in May, we have the OSFink workshop in Melbourne, which will be a hybrid event. So feel free to register and follow the different presentation and discussion. Et voilà, thank you very much for your attention. Let's talk now. Thanks.
Thank you. Questions? Francisco?
Hi, Julian. Thank you for the nice talk. So now I have the same question for you. What are the services that are most used by the community of users?
That's an excellent question. Thanks, Francisco. So yeah, I guess it's a bit like you. People use a lot the web portal. So we have typically, I don't know, several thousand requests per day on the servers. And we can see also burst of connection when there is something important from a paper or something like that. We can see like people are searching, doing cone search. And the live stream are not much used because I guess, you need to have a particular interest for follow-up. That's not like 1,000 people that will do follow-up. So in the end, the live stream are rarely used. However, the new data transfer service, and I think that's linked to the Alex question to Tom, the first talk. This is heavily used. So it has been deployed like a month ago, and we had 1 billion alerts downloaded since then in 1 month. This is just huge. So I think there is a need in the community for getting the alert. And for many reasons, when I was discussing with the users, many of them were using this transfer to train machine learning, for example, algorithm, because that was difficult to get data set from alerts, but also for running some exotic analysis that brokers do not provide currently. The idea is once this analysis, if this analysis is interesting, then it can be propagated back into the broker. So that allows also more science cases to be designed. Yeah, so this is it.
Okay, thank you. Any other questions? If not, then we have one more brief talk from the previous session. If our next guest from Link Frameworks is ready to give it, Alex, are you here?
Yes, I'm here. So I didn't make a video. I can drop a link to some slides from a presentation to the supernova subgroup a while ago into the chat.
Or I guess Riley can stop sharing his screen and you can just run the presentation ordinarily.
Okay, that might be easiest.
You should be able to share the screen.
Yeah. Okay, so the Redshift assessment infrastructure layers, or Rail software, the short version is that it's a modular toolkit for building end-to-end pipelines to obtain and stress test PhotoZ data products, which are needed for both static and transient applications of Rubin data. It was initiated by Desk, but it's totally public. It's open source. Link Frameworks software engineers are working on it as well. And it's not restricted to Desk. So the reason for it was the Desk PhotoZ Data Challenge 1 experiment revealed some open needs for PhotoZs for Desk and across the Rubin community. Meanwhile, Link Frameworks aims to build tools that are useful for lots of different science goals. And so PhotoZs are among those. So we need a way to stress test photometric redshift estimators, make good choices under realistically bad data conditions, and it has to work at scale. So there are three main subpackages of Rail. There's a creation subpackage for modeling mock data. So there's a notion of a true probability distribution to recover instead of just true redshifts. So what uncertainty is in the data, and can we characterize that? And you can include realistically complex imperfections of training data and templates and the real data. The estimation subpackage is wrappers around many different PhotoZ estimators, so you can test them all under the same conditions without having to herd cats in a big data challenge. There are some already wrapped and more coming, but if you have feelings about any of them, you are also invited to join in and wrap them. And the last of them is the evaluation subpackage, which includes metrics, and we're currently looking to expand this to include metrics for different science cases, so not just Desk. That's it. Thank you.
Okay, thank you. Questions? I will have one question. So am I correct? This is we're talking about PhotoZ in application to galaxies, right?
Yeah, but if there are estimators that operate directly on light curves, that is also something that we would be happy to include in Rail. We don't know of any methods that already exist doing this, but once there is one, we can wrap it.
Mm-hmm. So in application to the TVS science, the most interesting thing is probably determining PhotoZ for AGNs. Do you have some? I know that historically AGN PhotoZ is very problematic. So are there some specific metrics that you are developing for these cases, or it's just for the overall population of galaxies?
No, so we are asking for input from the other science collaborations. So AGN, TVS, galaxies, possibly strong lensing in the future, to help, especially with metrics, so that you can run experiments and test what really matters for that science. So there are some general metrics that are like mathematical, and then in Desk we're connecting the outputs of Rail to different dark energy probes to see the impact on the science. And now we want to, we need input from the community of other science collaborations to know what other metrics are useful and help you guys implement those so you can run the same kinds of experiments.
Okay, thank you. I think Anjoka has a question.
Thank you so much, Alex, for a nice talk. Could you go just back to the previous slide? Could you explain just a little bit, you are using the Bayesian framework for the construction of the metric and estimating the probability density functions related to the photo Z. And could you just explain a little bit these performance measures like bias, IQR, MED?
Oh, yeah.
For example, could we also use some other more metrics which are more related to probability density function measurement, how they are similar, etc. And I apologize if I didn't understand. Thank you.
No, sorry. Yeah, this was like the 2-minute go through it quickly talk. So the bias, interquartile range, mean absolute deviation, and outlier rate are the sort of traditional point estimate metrics. So there's a bunch of ways to turn the probability density functions into point estimates. Like there's mean and median, but also there's a survival function based one that was used in an early HSC paper. So we've got a few ways to do that, which people use for like general big picture summaries. What the probability integral transform plus the Kolmogorov-Smirnov statistic, Anderson-Darling, and Kramer-von Mises. So that's for the distribution of integral up to the true probability or up to the true redshift of each of the PDFs. So that should be a uniform distribution for a statistically self-consistent population of probability density functions. And what we found in this experiment was that that's not generally true for real estimators. So even under idealized conditions. So this is another sort of summary statistic over a population. You can evaluate it on subsamples. So like different transient true classes and check that that estimators are performing self-consistently among each subclass. The conditional density estimate loss is something that operates on the derived probability density functions and the photometry. So it's like relative to the space of the data. And one of the sort of packages that's associated with Rail is QP, which supports different parameterizations of probability density functions. And that includes some metrics like the Kullback-Leibler divergence and just a mean square error for pairwise probability density functions. So you can compare the results of different estimators to each other. And since if you use mock data generated through Rail, you have the true probability, posterior probabilities. You can see how well each estimator approximates those. So yeah, there's lots of these mathematical metrics, and we want there to be more metrics tied to the science for a variety of science goals.
Thank you so much, Alex.
Okay, thank you. Any more questions? I guess we'll have to go into discussion section since we have already eaten we have eaten our coffee break and part of the discussion time, thanks to the initial delay. So right now there is, I suggest that we still go for a short break to stretch our legs and grab a coffee or chamomile, depending on where you are. And then we will reconvene in 10 minutes for a brief general discussion and then breakout rooms. Is that sounds good for everyone?
Yeah, thanks, Alex. Sounds really good.
Thank you, Alex.
Excellent. Excellent. Then we will be back in 10 minutes.
Thank you.
So I guess it is time to reconvene. Are people already back? Okay, okay, okay. So I guess in a few more minutes, more people will be back because I see that some participants are not yet here. So this is a question where we have to decide how to proceed from now, because we have 1 more hour left for discussion today, and we will have plenty more time tomorrow. So the idea is that we could go to the breakout rooms right away, or we can have a general discussion first. The question is what is better, because I know that there is a significant overlap between conversations that would be held in different with different speakers. So let's run a short vote. Who votes for going to the breakout rooms right away?
Well, what would the discussion be about, Alex? First, we need to.
Right. Sorry. So my idea was to split us in 3 groups, because if we create a breakout room for each speaker, I believe it's gonna be a spread too thin. I thought about splitting us in 3 groups: classification and periods, with Angelika, Konstantin, and Thomas being the leads of this group. With the second group on data interfaces with myself and you, Yanis, and probably with Drew as well, because I didn't expect that we will have linked talks in advance. And with the third group for brokers. I think it is more or less a good balance between splitting people, not creating too many groups and not creating too few. How do you feel about that? Okay, several people are okay. Okay, I guess there are enough people that agree with this. Then we're back to our initial question. Do we want to have general discussion first and then go to breakout rooms, or go to breakout rooms right away? So who is for going to the breakout rooms right away without waiting anything? 1, 2, 3, 4, 5. 5. And who would prefer to have some general discussion first and then go to the breakout rooms maybe in 20 minutes? 1, 2, 3, 4, 5, 6, 7. I guess general discussion first wins. Then I guess it is. I suggest that we start with 20 minutes general discussions, and then breakout rooms are all ours. So if there are some questions to some particular speakers who maybe would have some more explanations to give, or are there questions for the groups of speakers? Because I definitely have a question for the brokers in general. Please raise your hand. Hey, hands. Yes, Yanis, please.
Yeah, I was just wondering. I'm interested in all 3, right? Breakout rooms, and I would like to at some point shift around. Do we have a plan for shifting around breakout rooms, or?
Yes, it's a great question. So you can enter the breakout rooms and leave them as you wish. But there is no good way to just, leave everyone to enter all the rooms right away, like at the same time. So you will have to decide by yourself in what order would you like to attend the groups.
Okay.
It is unfortunately the same problem that we had during the last workshop in Gazertown, because sometimes people wanted to wander around and left some of the conversation places empty. This is effectively why I suggest to start with the general discussion, because this is a place to start talking to everyone and then split out for more specific questions. Okay, Francisco, please.
Thank you. Yes, I have a question, whether at the end of the broker sessions, there will be like a summary for everyone, because I will also like to be in the 3 breakout rooms.
You mean in the end of the discussion session?
Yes, yes.
Yes, we will reconvene maybe 10 minutes before the end of the workshop.
Okay.
So I guess I will start with a question for brokers to break the ice. So listening to all the 3 talks, I was curious, is there any chance that different brokers may collaborate with each other and give us a large talk that would be a comparison between functionality of the different brokers? Because I realize that if I am an outsider, I have no real idea where would I prefer to look for some functionality. Yes, Francisco?
Yeah, I don't know if I can answer this question, but we have tried to collaborate, but at the same time, you want to keep some unique features about your own broker to make this, to give this diversity. I think there's a big risk of like this kind of solution that one takes all, and it's good to have diversity of brokers, but I completely agree that we should provide perhaps a unified web page to show what is available, and then redirect people to different services, and perhaps why not include broker services in AstroPi or something like this. I don't know if Julian also has some comments.
Yeah, I just want to comment on that. So there were a workshop organized by different broker teams, including LRC and Think, already 2 years ago now, where we started this effort trying to, well, discuss the difference, the features, but also the common things between the different brokers. I think all this material is still online, so that could be a good starting point. What would be good is with this end of the year workshop that Francisco mentioned, to make, to continue this effort and try to clarify the differences and the common points between the different brokers to the community.
Okay, thank you, Tom.
Yeah, I'd like to echo what Francisco said about I think having the diversity of brokers is a really good idea. Just because I think there'll be lots of different ways to implement different ideas, and I think having lots of ways for people to express those ideas will just be better overall for the future of time domain science. But I also like the idea of having sort of some kind of central place where people could go and learn about all the brokers and decide which one might be the best match for what they want to do. And so this might be something where the Rubin Observatory itself might want to have a web page on this, considering that they have selected the brokers that they want to be the ones to take it. So maybe we should ask them to put a web page on their science platform that we can all contribute to, and that would provide a shortcut for everybody who wants to understand what broker does what.
Federica?
Hello, hi, yes. I don't know, I'm not speaking officially, but I do think that maybe there might be some problems in hosting this web page directly on Rubin Observatory, because the problem that I see right now is that I actually would like it to include also brokers that are not directly endorsed by Rubin. And Rubin has endorsed a subset of the brokers, but and I think if it was Rubin specific, it would only host those. You know, we are talking about Rubin, so we do want to sort of use the brokers that have been endorsed by Rubin, but there are secondary brokers that have been planned at other things that might belong to that web page as well. On the other hand, maybe the corporation might be a good venue for this. The website of the corporation might be a good venue for this work because it's related and to Rubin, and they might provide some level of support for the page that wouldn't fall on the observatory. But I strongly support the idea of having a page where people can enter and look at what the brokers are and how they compare and choose what they want to use, because I expect there will be a lot more people involved in Rubin as we get the data that have not been really paying attention to the conversation until now. So we need an entry level, an accessible entry level information portal for them. And also because Rubin is directly trying to engage communities that are not traditionally involved in astronomy at this scale, and they will also need an entry-level accessible portal.
If I may add, I guess as usual, the problem is going to be who's going to make this comparison and who is equipped with making this comparison of different brokers, because obviously no one knows all different brokers better than broker developers. So I guess it is definitely something to discuss at your conferences and figure out at least a list of points at which it is meaningful to have any comparison between the brokers, and then maybe ask, look for volunteers among your users who would be able to provide some relevant insight about what is important to them and what is important to list on this hypothetical page where brokers would be described and compared to each other. Yes, Julian, and then Kostya.
Maybe Kostya already said something.
Okay, I just would like to ask another general question to brokers if we finished the previous discussion.
No, well, then I want to take the hand because I wanted to complement. Sorry, Kostya. Although it's a good idea to have this centralized page and try to think about the difference between brokers, although I would like to mention that in practice, you don't choose a broker based on a cheat sheet or let's say a table where there are crosses and check marks. I think in general, people choose brokers because first they have a feeling. For example, they see work from someone else that is using one of the functionality, and it all starts like that. For example, discussions among the inside the community. So it's a good idea to put this, but I wouldn't put too much emphasis to choose the thing in the end. It's more about, I don't know, feelings and well, what we do usually.
Okay, thank you, Julian. Duly noted. Kostya, I guess your question's next.
Yeah, so maybe some general, not real general, some specific question. So like right now we have a situation when we have, the same alerts going from ZTF and in the future from LSST to different brokers, and then inside brokers we have very different representation of light curves and all additional properties like cutoff cross matches and everything, and for end user it is unclear which broker to come to, yes, and which broker to work with. And even if a user makes one decision about going to one broker, it looks like a kind of vendor lock. Yes, you couldn't easily get your algorithm and run it in environment of another broker. I understand that different brokers are different and they have a lot of diversity, and it is fine. But maybe we could think about their interface or a scheme, some minimal scheme, maybe only photometric light curve data and nothing else, which we could use in all brokers, which we could ask all brokers to implement, so users could, bring their algorithm to any of them. So maybe it's connected to Francisca's idea about putting brokers to AstroPy, or I would say to AstroQuery, yes, or something, yes, to have, more or less homogeneous API and interface and data presentation. Yeah, so sorry for such a long question. I hope you've got the idea.
Very relevant, thank you, Kostya. I would just add that maybe not even AstroPy, but maybe a tutorial at RSP or maybe just Jupyter tutorial that would show how different how the same functionality or more or less close functionality is implemented across different brokers.
it's not a question about what is different. It's a request to make some parts non-different, some parts to make some parts homogeneous, or make an API which would work the same way for all brokers, maybe for very limited part of the data. Yes, maybe it would be scheme which each broker could, extend to their own data, for example, own cross matches or classifications, but all will have the same fields having the same photometric data, for example, and you could parse it in the same way. So it's this kind of request, and it would be interesting what broker teams think about it.
Francisco?
No, I completely agree. Perhaps that could be one discussion session during the conference to build something like this. So hackathon or something, some kind of universal parser that provides some minimal functionality.
Okay, great, thank you. Thomas, I saw your hand. Yes, please.
Yeah, thank you. So I raised my hand during Kostya's question but he mentioned almost everything what I wanted to ask. So so thank you, Kostya, for your question. That was one of my main questions, how these light curves look in each parallel brokers. My other question is, and I think somebody made this question during the talks. So as I mentioned during my talk, that we are using vast amounts of data to classify different types of variable stars. It would be a very, very good solution. So not solution, it would be very good if we could reach not just some variable stars on the web pages, just to have some. It would be very good to have some kind of query where we could reach lots of data to be able to classify it all together. And I don't know if the different type of brokers have some kind of solution already to that. So the LSST site is not so easy to use for this way, and classifying hundreds of thousands of light curves would be much more easier to have such kind of query which we could use. So this would be my question.
Yes, Julian.
So thanks, Thomas. I think it depends if you need a lot of data for the training or for the classification part. For the training, for sure, you can download a lot of data from brokers. I described, for example, one service that we provide in Think that lets you downloading, well, almost infinite amount of data that you want. And then you can perform your training based on that. For the classification, I don't think classifying 100,000 light curves is a problem for any brokers. So as long as you have an idea and you provide pre-trained model, for example, this is the kind of thing we can all do in NTRS, in LRC and in Think. We can upload basically your model, and then classification will be performed in real time. In the Elastic channel, for example, we demonstrated that we're up to high rate stream, for example. So yeah, depends on what for the big data.
Thank you very much, Julian. You just answered my second question. Thank you. My main concern was that so our main priority and our main expertise is sorry, I will start my video, so just to see each other. Hello. So our main priority and our main expertise is in positing variable stars. And I see on your slides and on other broker sites that your classification is working quite well, differentiating between different types of sources. And I was thinking, what are we doing? How could we help to be able to improve these classification results? Because, for example, our last classifier was classifying not just the main types, just to create clusters of different types. Just we could identify subtypes and other much more specialized variable stars as well. So if you could provide us training data, I think we could come up with a pretty reliable solution in a couple of weeks, and we could insert these results into any broker. If it can help.
Yeah, no, definitely. I think, well, I can speak for myself. It would definitely help. So we do have a lot of data, although this data is limited if you think in terms of LSST, of Robin, because we mostly work in production with ETF, with the Zwicky Transit Facility data. We have some simulation synthetic light curve from the elastic channel, but I think you are using that as well. So you know already the limitation. So now the big question is, how do we enrich those training sets toward Robin and make sure that the moment Robin start to take observation, we are already ready to provide those fine-grained classification that we would like to have. So it's more about, it's not much about how much data we need, but how are we ready with the quality of the data currently?
I think what would be very very interesting, not just have a vast amount of data, we should have quality data and diverse data as well. So we have tons of Cepheids, for example, or RL stars, but a couple of variable stars are obviously missing. And this is a huge problem for us because we are trying to do our best to be able to classify these stars. But it is clear that, for example, the elastic data set is pretty much focused on EGNs or supernovae. And just a couple of variable stars are present in these data sets. So it would be very, very good if we could work together and make a much more diverse data set.
I do agree. So Elastic was done by Desk, so it fulfilled the needs of Desk, which was extragalactic mostly. But I agree, something along this challenge, but for other types would be much appreciated. Yeah.
Alex?
Yeah, so Elastic is not over in the sense that there's plans to kind of try it again, and the models are something that can evolve. So you, like, if you get in contact with the team, so you can contact me, and I'll put you in contact with probably Rick or some of the other people who've been working on models, like we can get more models incorporated. That being said, it's all synthetic data and isn't, there are going to be surprises in the real data. So in terms of models, like things should be flexible, and we should, think ahead toward that as well. But yeah, like it's not static. We can come up with new things and incorporate them.
Thank you. Very relevant. Federica?
Hello, yes. So I think this is a call for us, for particularly the TVS community and the Stats Making Local Volume community, right? Because the Plastic and Elastic project have been going on for a long time. There's been a collaboration of the Desk and TVS since the beginning. But the Desk has contributed many more models. And so it's really a call for TVS to step up and populate these data sets with benchmark data on stars, which certainly we have as collective knowledge, whether they're models or observational data sets. But we just, there's a bit of inertia in putting together a large effort within TVS to collect a comprehensive set of variable stars that can be integrated into these into these data sets. Although I do want to say that, and I think Consta is here and many others, that the elastic data set does have, has stepped up to include a lot of stars, including flaring stars. There's been a lot of work on trying to get those models to be more realistic and more comprehensive. So definitely that's an effort that is on the way.
Costa, please.
Yeah, I just echo both of you, Federica and Alex. So I'm kind of responsible for probably half of variable star models from Elastic and all new models after Plastic. And they are not so good and they are not so diverse. So please come, contribute new models and help us improving those models. What we typically need is spectral temporal distribution. Yes, so spectra could be, we just need to integrate them with filters so they do not need to be precise, have lines or anything. Yes. So if you have any idea how to do it better, how to do it more diverse, please, we really need your help.
Costa, would it be reasonable for example, you and I and a few others work on a Dropbox type of portal where people can we can give instructions on acceptable formats and people could drop their models on it so that they don't have to like go through the additional potentially, inertia steps that might increase the inertia, such as having to communicate with somebody and ask them when they can meet and how they can get, whether they should email or Slack or whatever, right? So maybe we can provide like a place where models can be dropped with sufficient information that they could be integrated, and then it would be for the Elastic team to contact the author if there are any questions.
I think it sounds great. So I think it could be maybe GitHub repo. So maybe we should consolidate, variable star or galactic models. So not supernovae models. Yes, let's say to some repository. Yeah, because if we are talking about galactic variables and transients, we are generally talking about generation of the same events distributed over galaxy with including some dust properties and density distribution, yes, which more or less common for different types of objects. So we don't need model autos to re-implement them from scratch. Yeah, so what we need, we just need some sampler, which would give us light curves distributed, having some, underlying distribution of physical parameters, which alter the model things would be reasonable. Yes.
Yeah, we should talk. We had done a repo in the past within TVS. In fact, possibly before Plastic, because we were also thinking of a challenge, and we didn't really get, we got the variety of things of formats that we got combined with the scarcity of response was kind of a showstopper. So I was thinking maybe even something easier, like something where literally you can have a drop link where you can drag and drop a file and some validation of the format in it. But we can talk about the details.
It could work. Yeah. Let's discuss it separately, probably.
Alex, I saw your hand was up, but first of all, I would like to ask everyone a question. So it is already half an hour till the end of the workshop. How do you feel about staying here and continuing general discussion? Maybe we're switching on some other topics from brokers so that it didn't occupy everyone. But it's just, I see that there are 20 people here, and I feel like we have a lot of overlap between different groups. So probably I would feel more comfortable if we try to stay all here and have a consecutive discussion on different topics.
Yeah, I think the ice is already broken, so we can talk a lot.
Okay, great. Thank you. Then please continue.
and yeah, if you let me one more question, and I will address this question to Kostya. Would it help, because next to the classification we are working on cross matching between different databases, and this is a big problem, and I think last time when we talked about this problem, it was already a topic. Would it help if we identify and provide variable star light curves, for example, from ZTF, which is, I think, the base of the elastic dataset as well. And this way we could make this whole dataset a bit more diverse.
So generally, it is a good idea, yes, but the question, as usual, how we go from ZTF's 2.5 filters to LSST's 6 filters.
Yeah.
Yes, so from GR and beta phi to UGRIZI. And it is not trivial, and it probably would depend on the model you consider. Yes, so for example, we for Elastic, we provided 3 different types of models, and all of them had different types of spectra, underlying spectra used. So of course we used some real data from different surveys, from ZTF, from Kepler, from OGLE, yes, and then we applied some model spectra to go from their passbands to LSST passbands. Yes, and so just ZTF data isn't enough, unfortunately. Yes, because you need to have some idea how to go to ultraviolet and infrared.
Okay.
Alex, please.
Yes, I think it might make sense for people who want another model included in a future version of Elastic to come to one of the Elastic meetings, which are, I think, nominally bi-weekly, and talk about what you need to do to, like, what defines a model in this sense, because it can't be totally passive on your part. It takes work to get it into the simulation pipeline. So we can work with you, but like, we can't just, assume that whatever you have is going to be smooth to connect to it. But I guess we can put in this Slack channel connection information for an upcoming Elastic telecon, and we'll check that we can have an agenda that's really just about how to include new models. How does that sound?
Sounds like a great idea, I think.
Yeah, yes, it sounds fine. Yeah.
Okay, Tom, please.
Yeah, so if it's okay to stay on brokers, I had a question for the broker people. We've heard a lot of mention of the word cross-match, as Tamas just mentioned in the previous question, but as far as I can tell, nobody has specified what they mean when they say, oh, we assemble all of these other data sets and combine it with ZTF or now Rubin. And my first question was, where in the documentation do you say what your current cross-matching algorithms are? Because I had a cursory glance during some talks just a minute ago, but I couldn't quite find it in 30 seconds. But also, are you prepared for it to go completely wrong with Rubin? And at the risk of this being a plug for my talk tomorrow, would you like to work with us to see if we could get our slightly better, we hope, cross-matching algorithm to work with the brokers to take into account all of the nightmare that will be the Rubin data in the future?
Definitely.
Francisco, maybe you first and then Julian.
Sorry, yeah. Well, no, just completely, I completely agree. We will definitely use something like that. And I think it doesn't make sense to be duplicating the effort to do cross matches all the time.
Thank you. Julian, please.
Yeah, I think so. You were mentioning what kind of algorithm we use to cross match. At least in FIC, we are not as clever as Sherlock, for example, in Laser, which has a very nice, cross-matching tools with a lot of building intuition inside. I can already tell you we just do spatial cross-match. Okay, so we try to find on a 2D plane, of course, if things are close by and we just release this information. So it's like the stupidest things we can do, but the easiest things we can do also. So it would be very interesting, yes, to discuss and see what we could do to improve that, definitely.
Right. Yes, the one I did find, the Think documentation has that you showed in your, it was in your talk, that's what made me think of it, to go and search for the documentation bit where you have the rows in the documentation say, what is it, the X4 CPS or something within an arc minute I saw, so that's what made me think of it.
Yeah.
Tom.
Thank you, Tom. Your
Nope.
mic is up.
Haven't got you there, Tom.
Oh, sorry, I turned on the video, not the mic, because I was yeah. So we also do a dumb thing in that we were just doing a spatial cross match, and so it's basically anything within an arc second. But we have a separate catalog for any extended object, so we can, if it's a larger footprint from a nearby galaxy, we can match against that as well. We'd certainly like to take a look at anything that would be more sophisticated than that if we could. It's also been a problem with ZTF because since their pixels are coarse and their scene is often bad, it's doubly difficult with their data to do the cross matching really well. But yes, we'd certainly be happy to look at something that you are producing to see how that works.
So the reason I ask is because it's essentially to-do effort in that what we have been tasked to do as part of our in-kind contribution is a static match. We take the yearly releases and we match them to ancillary data sets. But we're hopeful that we can turn that into a one shot, one object, 1 second match. So, but that's not currently something we've done, so it would require extra effort. So that's why I ask, but that's very positive. So I will dig out everybody's email addresses and contact you afterwards.
Okay, so it sounds good. Any additional comments or questions on broker topics? If not, then I will have a very small question to Yanis regarding your user database. So I was curious whether this database is being developed only for the TVS leaders, or for example, it is more like for everyone in the TVS, a sort of an address book regarding how to contact whom or who's part of which collaborations. So essentially, what are the most common use cases for this project?
Okay, so this is to replace what we currently have on the website because there are problems with modifying information there for the TVS chairs. So it was really important that we finish that soon. So this is why we focus on that. And the idea is every user has a profile there. They can go and keep their information up to date. So it's the responsibility of the user to keep their email address, all the information up to date. And that's all the users need to do. Now, the TVS chairs and the managers of the subgroups and task forces can go in there and they can send messages to their subgroups and task forces. So it's a way to communicate, it's a way to make announcements. But in terms of the users, all they need to do is just make sure the information, their personal information, is up to date. So that includes affiliation, name, surname, and email address. I think this is pretty much it, and which country they are logging in from.
But what about, for example, additional fields for whether this user is affiliated with different projects, like, I don't know, Elastic brokers?
So you can request to join a particular subgroup or task force. So a user can request that, and it needs to be approved by the chair of that group.
I feel like relying on the user is going to be the weak point.
I can sort of show you what it looks like, the alpha version. It would be quite useful to get some feedback on it. So whoever is interested, but the main users, I think this project is intended primarily for TVS chairs. The user section is rather straightforward.
Well, I think if it's a quick demonstration that we are all good with it, maybe we will have thoughts about it.
Sure. I mean, I can do it here if you want, or we can do it tomorrow, or we can do it in a breakout room.
Well, I'm both good with right now or tomorrow in breakout rooms. How is everyone? Do we have any, just not to leave anyone outside? Other questions on other topics? I'm pretty sure that I have also questions for classification people, but probably it is too late to start this separate conversation now. I will probably reserve them for tomorrow. So unless someone has objections, Yanis, I think the floor is yours.
Okay, so let me just see if I can share my screen. All right. Okay, so can you all see this?
I can see a blank screen, yes.
All right, it's a blank screen, great. So you click here to register. So this is basically if you're not registered, you click here to register, you provide all the information. You have to read the terms and conditions, code of conduct, TVS charter, agree to all of those, tick on the box, tick the box at the end, and you sign up, okay? So if you've signed up and you're a user, let me just try logging in as myself. Hopefully that will work. All right, okay, so you see a bunch of announcements here on the left side. So this is sort of the TVS chair view, okay? The user only sees this, the TVS Sans Collaboration request to join group. So if you click on that, you can join a group, you can request which groups to join and so on. And you can also send a message if you want to the chair of that group. The user also has a profile page. You can and this is basically what we need to keep, what each user needs to keep up to date, okay? So your username, first name, last name, email. You can upload a picture. I don't know if we're going to keep that. Some people have said it violates GDPR. I don't know. We can easily get rid of that. You put your affiliation there and your country, and you can update it. So it's really straightforward. You cannot make posts as a user. You have to be a chair or managing a group, okay? So you can create a new post, give it a title, content, and then it appears on the main page, which is here. Okay, so this part is intended, like, for announcements by the TVS chairs. Okay, so this is the place where you can go and see it. So the TVS chairs have all these extra functions as well. So you can click on the members and get the information. Click on subgroups and task forces, so it sorts out all the users for you. Multiple users can belong to multiple task forces. You can set the group email. Here, you can choose, who your recipient is. You can attach files. Yeah, so you can send an email to that. We need to connect it to some sort of mail server as well, which we need to discuss. You can activate and deactivate members. So you cannot delete members, only the admin can do that. So the way to remove a member from the active members list is to set them to inactive, okay? And you can also, reactivate them, and then they join all the groups and task forces they were members of before. You can also create a new group. You have to give it a group name, and then it will also appear in all the search options. And you can use this to assign members to groups. So these are the requested functionalities that we've had up to now. Now, obviously, I haven't included any graphics there or anything like that. So if you want us to include any, nice pictures or anything for the interface, it's very minimalistic at the moment. But if you want us to include that, we'd be happy to do that. So that's pretty much it. I'm happy to answer any questions.
Well, I have a bit, how to say it, awkward question. So wouldn't it be possible to make the same functionality with Google Forms and connect it to Google Tables?
Possibly, I do not know, but it has to. The main problem is GDPR in Europe.
Ah, I see.
Okay, that is the main problem.
Yes, I see.
So Google is pretty much out of the question. Everything that we actually use Google for, it does not satisfy GDPR. So we are potentially
Broken the law.
yeah. So yeah, maybe we should have this discussion. I mean, none of us is a lawyer, so we've been told, like, when we approach lawyers here to discuss like how do we protect data rights and everything, they told us don't use Google, basically, because we asked if we could do it, through that, and they said no. So we developed this, and we've been going back and forth with the lawyers here, reading all the GDPR fine print, trying to figure out what we can store, what we can't store. So if a user, for example, requests to be removed, there is a function that removes basically all their data. Nothing gets left behind. Okay, so it has to be like a clean removal and so on. Yeah, Sarah has a question.
Yes, Sarah, please.
Yes, thank you, Yanis. This will be very, very useful for us. It will make our work very easy. I have a very basic question. Sorry if you cover it and I maybe missed it, but the very first step, when a new member apply for becoming a TVS member, very first step, is it also managed through this? Because I understand that any member can change affiliation and email, which is very useful, which is something now it's not so easy to do. It's impossible to do, basically. But the very first step, so the stage at which we as chairs should just look at the submission proposal and to let the new member to become effectively a TVS member. Is it also covered?
Right. Okay. So what we've got at the moment, let me just share the screen again, if I can find it. There we go. Okay. So what happens when you click on register? Okay. So you have to give all this information, confirm that you accept all the terms and conditions. And what happens when you click on sign up is you will get an email to confirm the email address. And the second functionality is I, at the moment, have set the user to inactive. Okay, so when you log in, you can, the only thing you can do is see the alerts, the posts. You are not a member of any subgroups or any task forces if you're a new user, okay? You can request to join some of those, okay, through the interface, and you can change the information in your profile. You cannot post anything, you can't do anything else. Okay, so basically what happens then is one of the TVS chairs will need to see which they need to keep an eye on whether there are new users that have registered. Okay, they need to keep an eye on a request to join subgroups, and then you can assign this person to a subgroup and activate their account. Otherwise, they will you won't be able to see them anywhere.
Yeah, I mean, but right now the process is that someone that want to join TVS will send us through the membership request a small project just to be reviewed in terms of if it fits the TVS science collaboration interest and collaboration very briefly. So in this case, what we as chairs receive will be just the notification that there is a new member interested to join, and that's it. So the name and the email.
Okay, so basically what we are talking about then is, let me just log in again here. Okay, we need another option here for new users. Instead of request to join group, request to join TVS. Okay, so that will be some kind of form where they have to describe the project, and this needs to happen after they have registered a profile, though. After they have registered here, they can they have an option to request to join TVS. And basically this will mean if we say, well, if you guys say yes, you can join TVS, that you can set the account to active. Is that what you're talking about? Something like that?
Yeah, basically, the point is that this that you are suggesting to add here should mimic the membership request form, which is very small one, already available in the TVS website.
If you can send that to me, Sarah, a link, I can just try
Yeah,
to
yeah, sure. By the way, I see the comment by Rachel, and yes, it will make our life so much easier. So thank you very much. And yeah, I can provide you with a link, the direct link for this membership, which is just right now is the request, like the name, affiliation, and email, and then this very brief description. And in that case, we directly ask also to indicate the subgroups and task force. But in this case, I see already you can then, after this very preliminary step, then you can choose the subgroups and task forces this way directly here. So thank you very much.
We can merge the two forms. I mean, I can modify the existing form for this subgroup. I mean, let's talk about it after, because I don't think it, most people are probably not interested in that, but we can definitely talk about that later ourselves.
Thank you very much.
Okay, thank you. So question is, any other questions on other topics? Because I completely missed, I actually was listening to your discussion and completely lost track of the chat where you suggested to organize a separate breakout room.
It's okay. I think this kind of, affects everybody to some extent, even if it's just to maintain the information. One of the problems is how we can enter the user information in there. Apparently, GDPR requires that users actively join this, which means we cannot use a CVS file with all the existing members and everybody has to register again. I don't know if there's a way around that. If anybody has any ideas, that would be quite interesting. Putting every user or requesting that every user re-registers, or this will is probably not great.
Well, probably the best workaround would be to somehow link it with RSP's mechanisms for verifying data rights and memberships, because they have to have this information. And when you sign up for using some data or using RSP, there would be a separate field to like enter your information so that your science collaboration leaders could connect with you. But because in general, it's going to be the weakest point. Like people are not going to just every time update their profiles everywhere when they change affiliation or something like that.
Yeah, that's a good idea. Yeah.
All right, we have 5 minutes till our closing time. Any other quick questions? In this case, I suggest that tomorrow, after our general discussion sessions, after feature talks and TVS software training and requirement sessions, I did organize breakout rooms. So the topics that have not been covered today in the discussion, classification, periods, data interfaces, apart from user database, that we will continue this discussion tomorrow in breakout rooms. Okay, and in this case, very good. In this case, I think we can wrap it up for today. I feel like it has been very productive and active workshop day with a lot of great talks and excellent discussion. So thanks everyone for joining. Thank you for giving your brilliant talk, and I will see you tomorrow at the same time.
Thanks for organizing, Alex. Take care.
Thank you.
Take care.
Thank
Thanks.
you.
Take care. Bye.
Thanks.
Alex, we are
Yes.
stopping now recording.
Yes, 1 second.